and east of the Mariana Islands, the seafloor falls away into one of Earth's most extreme frontiers. Beneath these sunlit ripples lies the western edge of the Pacific Plate, where it dives under the Philippine Plate and carves a trench more than 1,000 kilometers long.
In the heart of the Pacific, the water seems endless, stretching farther than any horizon can hold. But far below these sunlit waves lies a world more remote than the surface of the moon. The Mariana Trench, a 2,500-kilometer scar in Earth's crust.
From the quiet of space, the Pacific Ocean seems endless, but tucked within its blue expanse lies a slit in the planet's crust. We close in on the Mariana Trench. Down here, the seafloor falls away like an inverted mountain range, plunging more than 10,009.
From orbit, the Pacific looks endless, a vast canvas of blue and slow-swirling clouds. Hidden beneath it lies the planet's most extreme frontier. Passing over the Mariana Islands, the ocean floor suddenly drops away. Here, the Earth's crust bends and folds, creating a chasm nearly 11 kilometers deep. This narrow scar is the Challenger.
Sunlight is bold at the surface, spilling into the ocean in long, dancing shafts. But the deeper we go, the more the sea claims it. At 40 meters, colors already begin to drain at 100. The day above feels like distant dusk. Sunlight cannot reach beyond.
Trench. Far beneath the Pacific, two colossal slabs of Earth's crust converge. The dense Pacific Plate is forced downward, sliding into the mantle beneath the lighter Philippine Sea Plate. This downward plunge, called subduction, carves a...
We leave the sunlit world behind, slipping beneath the blue into a realm where light dies quickly. 100 meters down, the pressure is already 10 times what we feel on land. Metals groan, seals tighten, and every bubble hurries upward like it knows.
At the surface of the ocean, the weight of the air above us presses with about 1 atmosphere of pressure, roughly 15 pounds on every square inch. Drop just a kilometer down and the weight multiplies. 5 kilometers, and it's half a ton on the same...
Far below where sunlight dies, the ocean comes alive with its own stars. Tiny drifters make lanterns of their bodies, signaling, dazzling, or simply glowing for the joy of being. Here, predators carry lights on their heads, an entire school.
Here, at nearly 5 kilometers down, the sea forgets the sun. Particles, the memory of mountains and storms far above, slip off the ledge and tumble into nothing. No waves, no tide, only the slow rain of dust and shattered shells drifting.
At the bottom of the ocean, darkness is broken only by the shine of mineral-rich silt and the shimmer of giants like this amphipod. Growing nearly a foot long, it is a relative of the backyard pillbug, rebuilt for pressure 100 times greater than at the surface. Its shell is thin yet flexible, allowing it to withstand crushing.
Drifting 3.5 miles below the surface, this is a snailfish, so fragile it looks as though it's made of glass. Scientists filmed it at a depth of 8,336 meters, the deepest living fish ever recorded. Its body is also...
Far below the Pacific surface lies the planet's deepest scar, the Challenger Deep within the Mariana Trench. At nearly 11 kilometers down, it plunges beyond the height of Earth's tallest mountain. If Mount Everest were set on the seafloor here, its snowy summit would still be swamped by...
In the first years of deep ocean exploration, craft like this one were little more than pressure-proofed capsules lowered on a steel braid. They carried brave observers into a world no human eyes had seen. Those early missions discovered forests of glassy sponges on volcanic cliffs.
On the morning of January 23, 1960, the bathyscaphe Trieste slipped beneath the Pacific, its white hull cradled by quiet waves off Guam. Inside the small steel sphere, Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh settled in among dials and valves, beginning a journey.
7 miles of water pressed down with the weight of mountains, and yet, here, one tiny hull descends. Every meter is darker, heavier, more silent. Until at last, the lights find a floor no human has ever touched.
Down here, the ocean presses with 1,000 times the weight of the air above us. Every square inch of this hull feels more than 15,000 pounds. The clear dome in front of us is 180 millimeters of laminated acrylic, its edge clamped by a stainless steel flange.
In the stillness of the trench, food must fall from above. Each of these drifting flecks, marine snow, is a tiny parcel of energy, the remains of plankton blooms, fish scales, the husks of oceanic travelers. Minute as they seem, together they rain 8 kilometers down.
Here, nearly 11 kilometers beneath the surface, light has never reached. To see, we listen. Sonar sweeps across the trench floor, carving the darkness with mathematics and sound. Each pulse returns a contour, a cliff, a rift, an outline of worlds hidden in the cold. The grid...
Beneath the calm surface of the western Pacific, two giants meet. The Pacific Plate, riding the planet's outer shell, drifts westward with the momentum of continents the Philippine Sea Plate pushes back. Here, at their boundary, the older, colder Pacific crust bends.
When a metal sphere meets the weight of hundreds of meters of water, the force is relentless and everywhere at once. The thin wall resists for a moment, then folds like paper. Near the surface, pressure is gentle. A little lower, it rises by a ton for every 10.
Sunlight only reaches the first couple hundred meters of ocean, the bright, busy surface world we know. Slip below that and the light fades, then vanishes. We're moving through the twilight, the midnight, and into the abyss, zones where creatures glow to find each other.
In the dark ocean crust, life runs on chemistry alone. These microbes feast on two simple molecules, methane and hydrogen. Specialized enzymes on their membranes snap methane apart, stripping off electrons. Hydrogen undergoes a similar split, feeding.
To read the history written in the seafloor, scientists have to bring the past on board. A stainless steel core, lowered through hundreds of meters of water, bites into soft sediment and draws up a column of time. Back in the lab, every layer is examined.
11,000 meters up, the world folds into shadow. The clouds are a silent sea, black and silver, stretching forever. Above them, the stars multiply, so many they feel near enough to brush with a fingertip. Out here, the air is too thin for sound to carry, yet it hums.
In the ocean's twilight, sound is king. A single pulse of pressure, born in an instant, travels farther here than light ever could. As the wave expands, water molecules dance, passing energy from one to the next in perfect succession. Every fin, every grain of sand feels its touch. Low frequencies flow like liquid marble.
They seem fragile, more light than life, yet each is a masterpiece of survival. Over millions of years, gelatinous bodies have been sculpted into astonishing forms. Transparent walls hide pulsating networks, drawing energy from sunlight, from currents, from the very...
From hundreds of kilometers above the Pacific, the ocean looks serene, just shades of blue decorated by scattered clouds. But as we draw closer, a scar appears. This is the Mariana Trench, Earth's deepest known point, so deep that Mount...
On the surface, the Pacific boils, wind tearing at the crests, thunder punching holes in the sky. Chaos writes white scars across the water, but descend only a few dozen meters and the noise dissolves. Here light falls in gentle columns, currents move like slow breath.
At nearly 11,000 meters, sunlight never reaches this trench. The probes bring their own day. Sensors sweep the cliff face, mapping every ledge. Mechanical hands collect fragile life forms that glow with their own light. Below, hydrothermal...
Born in a leaf, carried by rain, carbon drifts from the forest to the sea. Sunlight fades and pressure builds as it sinks through the blue. What was once part of a tree becomes food for plankton, snow for fish, and eventually a tiny passenger plunging into Earth's...
Here, 2,500 meters beneath the waves, the seafloor is anything but still. Fine mud lies strewn with shattered rock and the shells of long-dead creatures, yet every grain is the product of motion. Landslides that thundered down the continental slope, lava that cooled mid-flow, and endless rain.
Wrapped in polished steel and layers of seals, these are cameras built to survive where light barely lingers and pressure can crush submarines. Every circuit, every gasket is engineered for one purpose: to keep seeing when the ocean stops forgiving. Lowered miles below
trench, a necklace of volcanoes crowns the sea. Here, an oceanic plate dives beneath its neighbor. Water-rich crust is dragged downward, releasing fluids that melt the mantle above. That buoyant magma rises, feeding fiery summits that pierce the waves and build arcs of islands.
Stretching in a graceful arc across the western Pacific, the Mariana Trench runs for about 2,550 kilometers, roughly the same distance as from New York to Dallas and back. On average, its walls sit 69 kilometers apart, but they plunge almost 11 kilometers.
In the upper layers of the ocean, sunlight sifts through the water like a cathedral of glass. Here, a blizzard of life swirls, billions of drifting plankton catching each beam. But even a few meters deeper, the glow begins to fade. The crowd thins. Energy...
Every second, the ocean is snowing. Tiny fragments of algae, bits of shell, fish scales, and the remains of plankton drift down from the sunlit surface. Their slow tumble feeds the deep. What begins as waste becomes wealth. Falling particles...
Along the wall of this trench, water behaves like wind over mountains. Velocity accelerates as it slides down the slope, pulling threads of plankton and mineral-rich sediment with it. You can actually see the current drawn in ribbons of marine snow, curling around ledges.
Nearly 7 miles beneath the surface, the world is darkness until our lights touch it. The remotely operated vehicle drifts over the trench floor, its thrusters whispering against the water. Silt hangs like smoke in the beams, revealing a landscape that has never seen the sun. Manganese not.
In places where most life would wither, these communities of microbes build vibrant cities. Fed by sunlight and minerals, layers of cells knit into mats that trap heat, hold moisture, and share nutrients. Beneath ice, they slow their metabolism to a crawl, surviving on trickles of chemical energy.
To prove a material can survive the unthinkable, we bring the pressure to it. Literally. In this chamber, a thumb-sized cube of graphene ceramic composite meets half a gigapascal of force. Sensors trace every crack, every realignment in its... At sunrise, the surface of the Pacific looks endless and calm. But slip beneath that glittering skin and descend, and the light quickly fades. Past the continental slopes, past the midnight zone, the pressure climbs to more than 1,000 atmospheres. This is the Hadal realm.
Slip beneath the surface and the ocean feels welcoming, at first. But just 10 meters down, the weight of the entire atmosphere is already doubled. Your lungs shrink, your sinuses squeeze, and every cell is under assault. By 20 meters, the nitrogen in your blood begins to fog your mind. Beyond that, human bodies simply...
Freeze proteins can be as beautiful as they are powerful. Deep in frigid brine, extremophile microbes deploy remarkable molecular tools. This cage-like chaperonin shields other proteins as they fold. Nearby, a curling antifreeze protein latches onto...
Far below the waves, where sunlight never reaches and pressure could crush metal, there are fish unlike any seen near the surface. Their bones are more like bendable straws than steel beams. Their bodies, soft as jelly, yield instead of break. Flexibility is their armor. It allows...
The ocean is vast, but its deepest scars are few. Here at the water's surface, a cruise ship floats. 1 kilometer down, a nuclear submarine would already be straining. Drop Everest in upside down, and its snowy summit would still sit more than a kilometer below the waves. The Puerto Rico Trench falls to 8.6 kilometers. The Kermadec Trench...
In the dark waters of the open ocean, light itself becomes a living currency. Here, delicate drifters, transparent, fragile, yet full of fire, produce their own constellations. Comb jellies scatter rainbows with every beat. Tiny copepods carry lanterns inside their bodies.
Samples still turbid. You can see the suspended clay particles swirling.
Under the scope, there's a whole ecosystem. Look at the spirilla threading through the diatoms.
pH is holding around 7.4 after filtration. That's surprisingly neutral.
Let's flag it and run a full genomic analysis.
Beneath the shimmering surface, the seafloor splits open into a vast V-shaped scar. Each wall tells a different story. Sand and coral on one side, volcanic rock on the other, descending for kilometers into cold darkness. Light fades quickly here.
At the surface, the ocean presses with 1 atmosphere, about 100 kilopascals. Descend just 100 meters and the pressure multiplies tenfold. At 500 meters, 50 atmospheres squeeze every square inch. A kilometer down, the weight is 100 atmospheres. 5 kilometers?
Beneath the quiet surface of the sea, Earth's outer shell bends like a vast stone ribbon. Here, an oceanic plate dives under a continent, pulled by its own weight into the mantle below. Heat and pressure fracture the slab, water locked in its
breeze. At the sunlit surface of the ocean, tropical waters can reach about 27 degrees Celsius. But as we dive deeper, the heat quickly slips away. At 100 meters, we're down to the low 20s. 500 meters, only 8 degrees. By 1,000 meters, the deep sea settles near 4 degrees, just a few degrees above freezing. Past 2 and
In the lightless depths, survival favors the flexible. Webbed arms ripple like silk. Glassy tentacles spiral and recoil with effortless grace. Feathery limbs knit and unfurl in constant choreography. Even a throat can bloom to the size of a balloon.
Tension's good, lowering the lander now.
Beautiful drop. LEDs are on and cameras are live.
Depth 4,100 meters, temperature 2.4. We've got an isopod approaching the bait.
Capturing stills. Data flow looks clean. Currents are slow. Perfect for the overnight set.
Copy, bringing her back up.
Along the rim of the trench, instability builds. Grains of sand tremble, cracks widen, gravity takes over. Sediment peels away, collapsing in a rolling mass. A turbidity current is born, dense and fast, cascading toward the abyss. As
descend beyond the reach of surfers and sunlight. At 200 meters, we enter the bathyal zone, cold, dim, yet alive with corals and cruising fish. Slip past 4,000 meters and the seafloor flattens into the abyssal plain. No day or night here, only the glow.
Far below the surface, one slab of Earth's crust dives beneath another. Pressure mounts for centuries in silence. Then, in an instant, the locked edges slip. Rock grinds against rock, releasing energy that races through the water.
Drop a balloon and watch what happens. As it sinks, growing pressure from the weight of the water squeezes the gas inside, shrinking it before your eyes. The same principle is at work inside rock cavities, in engineered housings, even in the air bladders of fish. Less space, more pressure.
"3 kilometers down, darkness rules, yet the chemistry is alive. As the whale's bones break down, organic carbon flows into the sediments. Microbes transform it, releasing ammonium and carbon dioxide. Vent fluids rich in sulfur and iron rise, feeding mats of...
From the stillness of the deep ocean floor, life stirs. Segmented worms, hidden beneath the silt for days, push upward into the dim light. Bristles catch stray flashes of light, and tiny beads of bioluminescence pulse along translucent skin. Here, among
circling the Pacific like a fiery crown, volcanoes rise where the Earth is torn apart and pushed together. Here, the planet's restless crust plunges into trenches miles deep, fueling eruptions and earthquakes. In the shadows of these chasms, superheated vents nurture life, and scientists track.
At the break of day, the explorers let the brass transducer sink beneath the surface, chasing echoes into the deep. Each pulse traveled out like a ripple of curiosity, returning with secrets of valleys and ridges no human eyes had ever seen. Line by line, dot by dot.
From the edge of our atmosphere, we fall, past the curve of oceans, into the wrinkles of mountains, along rivers that have carved for eons. Curiosity pulls us closer. It guides us through canyons, into droplets, beneath the surface of the everyday. We descend waves.
Deep under the surface, radio waves fade quickly. To talk, submersibles turn to sound. Each craft carries an acoustic modem that converts digital data into pressure waves, pulses of tone that travel through seawater far better than radio.
Along the steep wall of a deep sea trench, microplastics ride the descending current like tiny comets. As the water plunges, its speed slows inside the trench, letting the fragments spiral downward. Here, calmer water and heavy sediments act.
Nearly 11 kilometers down, sunlight can no longer follow, yet life thrives in the dark. Here, at the trench's deepest known ecosystem, vents breathe out chemical energy instead of heat from the sun. Bacteria feed on the minerals, and everything else feeds on them.
Sunlight and it's centered in this light. The probe is tethered by a carbon-braided umbilical, its lifeline to the surface 2 kilometers above. 8 LED arrays carve cones of light through the particulate, revealing a snow of organic debris. Below, the bottom disappears. The trench wall drops forward.
Passing 440 meters. Sonar returns show dense structures ahead. Holding course. Target zone acquired. Beginning survey.
Beneath layers of cold, dark sediment, chemistry is alive. Superheated water seeps upward, rich with dissolved metals and gases. As it meets the frigid seawater, the elements collide. Iron blooms rusty orange, sulfur turns to bright yellow, copper flashes teal. Crystals build like tiny...
140 million years ago, this seafloor was flat and unbroken. As plates drifted, one began to dive beneath the other. A trench was born. With every passing million years, the chasm deepened. Magma welled up.
Light bends and slows here, sifted into ribbons by miles of water. Each beam falls like a question into the blue, and the blue has all the time in the world to answer. Nothing hurries. Even the great shapes, whale,
Scanner online, projecting grid. There it goes. You can see the trench wall breaking into those stacked basalts, returning a beautiful contour, dropping marker 1, settled, tether secure, sulfide chimney at our 3 o'clock, fluids venting at 60 degrees, spectacular, pulling back to complete the sweep, data looks solid.
From the sunlit shallows to the deepest trench, the number of creatures packed into each slice of ocean changes dramatically. Near the surface, schools of tiny fish can number in the thousands. Descend a kilometer and that abundance thins. Larger hunters and drifting squid.
Beneath the restless waves, a slab of oceanic crust begins its long descent. Pressed downward, it dives beneath the continental edge, dragging minerals and seawater into the deep. Heat and pressure wring water from the sinking rock. The mantle responds, melting. Magma rises. It breaks.
A world without sunlight, yet bursting with life. Here, deep beneath the ocean, microbes weave cities of filaments and glowing mats on the face of volcanic rock. They draw energy not from the sun, but from the chemistry of the earth itself. Sulfide.
Sunlight barely reaches this abyss, yet every flake falling through the water carries a story of the surface. Bits of plankton shells, soot from wildfires, carbon pulled from the air by forests and algae, it's all bundled into this slow snow. The trench is waiting. Here, at 6 kilometers down, the carbon
boulders clinging to the side of the trench like a cliffside city. Life here lives in vertigo. We let the drone hug the wall, its lights brushing over a centuries-old tapestry of coral, sponge, and stone. Sunlight is already a rumor, just a pale wash above us, yet every
As the drone moves along the cut, laser measurements update in real time. Depth starts at 0 at the camera's position and increases as we travel forward. Cross-sectional data and moisture levels are overlaid in blue, while a virtual plane marks the current reading.
Down in the black of the deep ocean, pressure crushes everything, even the folds of life's enzymes. Ordinary proteins buckle, their shapes collapsing. But some microbes have rewritten the rules. They weave in extra salt bridges, tuck their helices tighter, and let only the most flexible loops move. These pressure-adapted
A small white vessel slipped beneath the waves and into history. 2 explorers and a single question. What lies at Earth's deepest point? 4 hours later, nearly 7 miles down, their lights found a patch of silt and stone untouched since the dawn of the planet. Back at the surface.
Link test complete. Thruster power nominal.
Hours before they ever leave the surface, every detail is rehearsed.
Neck seal secured. Oxygen mix at 20%.
Suit sealed. Data double-checked. Weather measured to the minute.
Lowering in 3.
Only after all of that do they descend into the unknown.
The Grand Canyon, a mile of rock carved by a river over millions of years, vast, colossal. And yet, it barely scratches the surface of what lies in the Pacific. Drop through the waves, past the sunlit blue, past where light...
At the surface, oxygen makes up about 21% of the air dissolved in the sea. But as we slip beneath the waves, that life-giving gas begins to fade. Sunlight drives photosynthesis near the top, yet every meter below adds pressure and darkness, while microbes and animals continually breathe the supply away.
At the edge of a steep continental slope, cracks widen in silence. Then gravity takes over. Sediment peels away, tumbling into the depths in a churning avalanche. The collapse drives a turbidity current, a dense cloud of mud and sand that rushes along the seafloor.
Nearly 4 kilometers beneath the waves, pressure crushes with the weight of 25 elephants on every square inch. Yet here, life thrives. Barophilic or pressure-loving microbes have membranes built like flexible armor. Special protein channels
6,000 meters down, the continental slopes fall away and the Haddle trenches begin. White light from the sub cuts a luminous tunnel through the black, revealing a new alien world. The temperature hovers just above freezing. The pressure here would crush a steel hull, yet life persists. 1,500 atmospheres of pressure would crush most molecules. But this microbe's DNA is built differently. Extra guanine cytosine pairs form tighter hydrogen bonds. The double helix supercoils like a spring, and protective proteins hug its backbone.
Each 100 meters we drop, the weight of the ocean stacks like invisible stone, until the hull outside that window feels the squeeze of 14,000 pounds per square inch. Temperatures hover just above freezing. Electronics must survive both salt and crushing pressure, and if something fails, there's no...
More than 10 kilometers beneath the surface, the world narrows to rock, water, and darkness. Down here, the ocean feels endless, yet everything is alone. The Challenger Deep is Earth's deepest point.
Down here, 3 kilometers beneath the waves, every move is a negotiation with physics. Pressure crushes metal like paper. Seawater near freezing locks up joints. Cables stretch, biofouling grows, thrusters clog in silt.
Beneath the weight of centuries, the seafloor keeps its quiet tally. Rust blooms where iron once gleamed, bone turns the color of sand, and glass grows a skin of salt and time. Life threads itself through the wreckage, brittle stars reaching.
In the stillness of the abyss, a clutch of eggs shelters tiny lives. Inside each, an amphipod curls, its eyes already reflecting the sparse light of the deep. With a decisive push, the young break free, fragile, glassy bodies beating their first strokes. They feed on drifting glimmers of plankton.
Beneath miles of water, the seafloor splits open into a darkness deeper than any night. Walls of stone, carved by time, vanish into shadow. Life clings to the edges, glowing softly as if guarding a secret. We call it a trench, but the name hardly holds it.